Hello, welcome to Unit 7, Lesson 3. I'm Professor Blackman. In this lesson, we're going to be talking about complex numbers. And more specifically, a lot of what we talk about is I. So I is defined as the square root of -1. And so if we have I squared, that is the square root of -1 squared, which is -1. And then I to the third is equal to, well, I times I squared. And so that's I times -1, which is -I. And then we have I to the fourth, which is equal to I squared times I squared. So that's -1 times -1, which equals 1. And if we continue this pattern, we get I to the 5, which is I to the 4 times I. And I to the 4 is 1, so this equals I to the 6 is I to the 4 times I squared. And so that pattern would be 1 times I squared, which is -1, and we get -1. I to the 7 is I to the 4 times I to the third, and I to the third is -I, so this is 1 times -I, so it's -I. And I to the 8th is I to the 4th times I to the 4th, which is 1 times 1, which is 1. So this pattern emerges that I is I squared is -1, I to the third is -I, and I to the fourth is 1. And this is a pattern when we're talking about imaginary numbers that you need to know. And so this pattern repeats. It's kind of like our numbers where they go 0 through 9 and then start over, 0 through 9, start over, 0 through 9. This is, a base of 4 that keeps repeating. And then in complex numbers, that's when we have a real number joined with an imaginary number. And it's very important that we always put those in A plus BI form. And so this is your real part, and this is your imaginary part. And together, they give you your complex number. And we can do a lot with these, but these are the basics that you really need to know for this lesson. Let's go ahead and look at some examples. All right, so square root of -3 can be written as -1 times 3. And -1 is I, so this is I square root of 3. Okay. Square root of -100 can be written as -1 times 100. And 100, square root of 100 is 10. And square root of -1 is I. So we write that as 10I. Here we have negative square root -1 times 81. And so that's negative brought over. Square root of 81 is 9, and square root of -1 is I. So negative square root of -81 is -9I. And then for this one, we can write it as -1 times 49 times 2. And so we get 49, which is 7. -1 becomes I, and the square root of 2 is left on the inside. All right, let's look at some more examples. Okay, so here we're going to write this in terms of I to the 11th. So that is, if we take and divide 11 by 4, we get 2.75. So with that 2.75, that lets us know that this is I to the 4th squared, so that's 1 squared, times, that gives you 8 I to the 3rd. So that is 1 times -I, which we can just write as -I. All right, so with this one, we're going to rewrite it. If we take and do 35 divided by 4, we get 8.75. So that's I to the fourth 8 times. 4 times 8 is 32, leaving an I to the third. So that's 1 times negative I, which is negative I. All right, I to the 64, we're going to take and do 64 divided by 4, and that gives us 16. So that's I to the fourth 16 times, which is 1 to the 16th, which is 1. 1 times itself 16 times is 1. This one's a little bit more challenging because it has the negative, but a negative occurring 71 times is a negative because it's an odd number. And then we do 71 divided by 4, which gives us 17.75. And so that is I to the fourth 17 times, leaving an I to the third. So that's negative 1 times I to the third, which is negative I. And so that gives us just I. Negative times negative, positive. All right, let's look at some more examples. So here we're going to add complex numbers. So we have the real part and the imaginary part. So if we add the real part, 12 and negative 8 is 4. And we add the imaginary part, 3i and 5i. You can treat that like you're adding x's or any other type of variable, because I is just a variable. We just know that that variable is defined as the square root of negative 1. So 3 plus 5 gives us 8i. Okay, here we go. Let's add our real parts. Negative 1 and negative 3 give us negative 4. And a negative I and a negative I give us a negative 2i. All right, so number 3, we have subtraction. So that's 6 minus 4i. And with the subtraction, we need to apply it to everything inside that parenthesis. So that's plus 5 minus I. Negative 5 plus I becomes positive 5 minus I by applying that subtraction. 6 plus 5 gives you 11. Negative 4i and negative I give you negative 5i. All right, apply the subtraction here. Again, first parenthesis stays exactly the same. And negative negative will become positive positive. Add your real parts, negative 5 and 4, that's negative 1. Add your imaginary parts, 2i and 3i, give you 5i. All right, let's look at some more examples. Okay, now we're going to multiply. So let's apply the distributive property. And that gives us 7i times 2 is 14i. And then 7i times negative 3i is negative 35i squared. Now, earlier we defined I squared as negative 1, and so that would be 14i. This is now a negative 1, so negative 35 and negative 1 is now a negative 1 there. So that's 14i plus 35. And when we talked about complex numbers, we always want them in a plus bi form. So we need to write this as 35 plus 14i. Not writing like this will be marked wrong. Distribute here, and we get 16i, because negative times negative is positive, minus 6i squared. So that becomes 16i. A negative 1 changes this to a plus 6, and then rewrite it in a plus bi form. Okay, so now we're multiplying two binomials. So we just do it step by step. 1 times 1, 1. 1 times negative 4, negative 4i. Negative 3 times positive 3i times 1, it'd be plus 3i. And positive times negative is a negative 12i squared. So this is 1 minus I plus 12. That becomes negative, makes that positive. So this is 13 minus I. Negative 4 times 3, negative 12. Negative 4 times negative 2i, positive 8i. The inside gives you 3i. And the last two terms give you negative 2i squared. So negative 12 plus 11i plus 2, I squared becomes negative 1 times the negative makes it positive. So now we have negative 10 plus 11i. Okay, over here, 5 times 5 gives you 25. 5 times 4i gives you 20i. Inside gives you negative 20i. And the last two terms gives you negative 16i squared. Okay. As you notice, the middle ones cancel out. You can put a star next to this one in your notes because this is one that will become very important in future lessons. And so now we have 25 plus 16, which gives us 25, 35, 41. Okay. Multiply this one. We get 9 minus 6i plus 6i minus 4i squared. So middles cancel, and you get 9 plus 4, which is 13. And again, this is an important one that we will see as we need them in the future. Okay, and so here is what I was talking about. Those terms that we just started on our previous ones, we call them conjugates. So you have a plus bi and then a minus bi. Because whenever we are looking at a denominator, we can never have I in the denominator because I is a square root, and we can't have square roots in our denominator. So what we need to do right here is we're going to multiply by the conjugate, which is 5 plus 11i. Same values, just change your signs from positive to negative. Okay, and so when we multiply that out, we get 15 plus 33i on top. And then on bottom, we can go do that math over on the side. 5 minus 11i, 5 plus 11i, so that's 25, plus 55i, minus 55i, minus 121i squared. Middles cancel, and we get 25 plus 121. So that's 146. So that's what's going to go on bottom. So now we don't have any i's in the denominator, but we need to write this in a plus bi form. Always write in a plus bi form. And so this would be 15 over 146 plus 33 over 146i. All right, let's look at the next one, multiplying by the conjugate. So we're going to multiply by 2, change the sign, minus 3i. 2 minus 3i. So on top we have 10 minus 15i. And on bottom, we'll go do that math over on the side. 2 plus 3i, 2 minus 3i, which gives us 4 minus 6i plus 6i minus 9i squared. Middles cancel, and you get 4 plus 9, which is 13. And so then we have 10 over 13 minus 15 over 13i, because writing it in that a plus bi form every time. All right, let's look at our final examples. Okay, so we're going to multiply the conjugates to get rid of the i's in the denominator. So negative 3 plus 2i, negative 3 plus 2i. And I'm going to do that math over on the side. So 4 plus I, negative 3 plus 2i, gives us negative 12 plus 8i minus 3i plus 2i squared. So the middles aren't going to cancel out here because that's not a conjugate. So we get negative 12. Combine your middles, you get 5i minus 2. So that's negative 14 plus 5i. So that's what's going to be on top. Negative 14 plus 5i. Now we need to figure out what's on bottom. So negative 3 minus 2i times negative 3 plus 2i. So negative 3 and negative 3 give us 9 minus 6i plus 6i minus 4i squared. Middles cancel, and that's 9 plus 4, which gives us 13, which we would then write as negative 14 over 13 plus 5 over 13i. So let's look at our last example. So in the bottom we have 5 minus 4i. So that means our conjugate that we need to multiply by is 5 plus 4i. And we multiply that top and bottom. All right, so let's go ahead and do that math over off to the side. So 2 plus square root of 3i times 5 plus 4i. And then we need to multiply 5 minus 4i times 5 plus 4i. All right, so 2 times 5 is 10. 2 times 4i gives us 8i. 5 times square root of 3i gives us 5 square root of 3i. And square root of 3 times 4 is plus 4 square root of 3i squared. So let's simplify that. So then we have 10 minus 4 square root of 3. I squared becomes negative 1 plus 8i plus 5 radical 3i. So then we have on top 10 minus 4 root 3 plus 8i plus 5 root 3i all over 5 times 5, 25, plus 20i minus 20i minus 16i squared. Middles cancel. 25 plus 16 gives me 25, 35, 41. So when we try and write this in a plus bi, it would be 10 minus 4 radical 3 over 41 plus 8 plus 5 radical 3 over 41i. And that's your real and your imaginary part. That's all I have for you today. Happy studying.